Welcome, everyone. Today we are tackling a critical aspect of responsible AI, verification. As generative AI becomes seamlessly integrated into our daily workflows, it is incredibly tempting to trust its outputs blindly. But true AI mastery requires rigorous validation. Let's dive in and learn how to select the right verification steps. Let's start by defining what we mean by verification within the context of responsible AI. What exactly is it? Verification is the deliberate, structured process of validating AI-generated content before you use it to make decisions. The basics involve a variety of actions, from simply clicking a source link to conducting a comprehensive, multi-tiered human review. Why is this so absolutely necessary? Because generative AI, for all its brilliance, is not infallible. It operates on probability, meaning it can occasionally omit vital context, reflect underlying biases, or generate plausible but entirely incorrect information. How do we counter this? By building mandatory checkpoints into our daily workflows where we actively interrogate the AI's output. In our deep dive today, we will connect this directly to Microsoft's core principle of reliability and safety. Selecting the appropriate verification steps ensures that we remain in control, using AI to augment our intelligence rather than blindly outsourcing our judgment. Let's take a look at the flowchart on your screen. This diagram breaks down the core architecture of responsible AI oversight. At the very top, we have the overarching umbrella of responsible AI principles. From there, the flow moves directly into reliability and safety, which is the specific ethical principle demanding that our systems operate securely. To guarantee that safety, the flow branches down into our primary focus, verification steps. Notice how this critical node splits into two complementary pathways. On the left, we have citation checks representing our technical, data-driven validation. On the right, we see human review representing our cognitive, expert-driven validation. Ultimately, both of these pathways converge at the bottom to produce a trustworthy business output. This illustrates that true safety requires a layered defense. To understand why we verify, we must understand the core threat we are fighting: over-reliance on AI. What is over-reliance? It occurs when users blindly accept incorrect, biased, or incomplete AI outputs without applying any scrutiny. The basics of why this happens come down to human psychology and system design. AI models generate text that sounds incredibly authoritative, confident, and articulate. This polished presentation makes it inherently difficult for users to spot factual errors. Why should you care? Because over-reliance leads to severe, costly business mistakes, compliance breaches, and a fundamental loss of trust in the technology. How does it happen in practice? It manifests the moment a user decides to skip a verification step to save time. Diving deeper, research reveals a perfect storm for over-reliance. When a user has low AI literacy, is performing a highly complex task, or lacks deep domain expertise, their likelihood of blindly trusting the AI skyrockets. We must actively design workflows to combat this. This decision tree starkly illustrates the fork in the road every user faces when interacting with generative AI. It begins on the left when the AI generates output. The critical juncture is the diamond in the middle, user scrutiny. If a user takes the top path applying zero scrutiny, they fall directly into the over-reliance trap, which inevitably leads to costly errors and harm. However, if the user takes the bottom path, applying active verification through citations and human review, they achieve what we call appropriate reliance. This leads directly to safe and validated success. The takeaway here is that the user's action immediately following the AI generation dictates the safety of the entire workflow. If over-reliance is the enemy, our goal is to foster appropriate reliance. What exactly does this mean? Appropriate reliance is a calibrated user behavior where you confidently accept correct AI outputs, but you possess the skill and skepticism to identify and reject the incorrect ones. The basics of achieving this involve deep user education. You must understand the AI's capabilities, its limitations, and the frequency and types of mistakes it makes. Why is this our goal? Because transitioning your workforce from blind trust to appropriate reliance is the only sustainable way to scale generative AI safely across a business. How do we do it? We do it by actively shaping the user's mental model and aggressively signaling when they need to verify. In our deep dive, we see this executed through specific mitigations, displaying clear in-product disclaimers, highlighting AI uncertainty, and ensuring everyone understands that AI is an assistant that generates patterns, not an infallible database. This flowchart maps out the journey to appropriate reliance. At the top, We have two distinct inputs, educate on limitations and signal uncertainty in the UI. Both of these inputs feed directly into building a realistic mental model for the user. Once the user possesses this grounded understanding, they reach the evaluation phase. When the user evaluates the output, their realistic mental model empowers them to make a choice. They can either identify an error and reject and refine the prompt, or they can successfully validate the data and accept and deploy the solution. It's a continuous loop of educated, critical engagement. Now we get to the core operational strategy, selecting the right verification steps for the task. What is this? It is the strategic practice of tailoring your validation methods to match the specific risk level of the work you are doing. The basics are intuitive. Drafting a casual internal email might only require a quick read-through, while generating a quarterly financial summary demands rigorous oversight. Why must we differentiate? Because if you apply maximum verification to every minor task, you completely destroy the productivity gains of AI. Conversely, if you under-verify a high-impact task, you invite disaster. How do you choose? You must assess the impact. Always ask yourself, what is the negative consequence if this AI output is completely wrong? In our deep dive, we establish a rule for high-stakes tasks like regulatory reporting, medical guidance, or financial modeling. Your selected verification steps must be exhaustive, including mandatory cross-referencing of sources and formal peer reviews. Let's walk through this risk assessment flowchart. Everything begins at evaluate task stakes. From there, we move into the risk-level decision diamond, which routes us down three distinct paths. For low-risk tasks, the appropriate verification step is a quick read-through before deployment. For medium-risk tasks, we escalate our effort to verify citations and sources. But look at the high-risk path. This requires a compounded approach, deep citation check plus human SME review. Regardless of the path chosen based on the risk, all routes eventually lead safely to deploy. This diagram visually reinforces that verification is not one-size-fits-all. It scales dynamically with the risk. Let's zoom in on one of our most powerful validation tools, the citation check. What is this? It goes beyond just noting that a citation exists. It is the act of actively clicking, reading, and validating the specific source material the AI referenced. The basics rely on a process called grounding. Enterprise tools like Microsoft 365 Copilot ground their responses by linking directly to your internal files, emails, or trusted web pages. Why is this step non-negotiable? Because citation checks are your fastest, most reliable method for detecting hallucinations, those moments where the AI sounds confident but has completely fabricated a fact. How do you do it properly? Never just assume a little bracketed number means the text is true. You must click the link and verify the AI accurately summarized the source. Our deep dive reveals a hidden trap. An AI can perfectly summarize a document, but if that document is 2 years out of date, the output is useless. You must verify both the AI's accuracy and the source's validity. This sequence diagram illustrates the life cycle of a secure citation check. First, the user prompts the AI. Second, the AI securely retrieves context from the source data. This is the grounding phase. Third, the source provides the raw facts back to the AI. Fourth, the AI delivers the generated output, complete with citations, to the user. Now, pay close attention to step 5. This is where the user steps out of a passive role and takes action. The user manually clicks and verifies the citation directly against the source data. Finally, step 6 confirms the accuracy. The system provides the map, but the user must walk the path to verify the truth. Citations are excellent, but they are not enough for high-stakes decisions. This brings us to human-in-the-loop, or HITL review. What is HITL? It is an operational safeguard where a human subject matter expert must physically review and approve an AI's output before it goes live. The basics of this concept firmly position the AI as a highly capable assistant or drafter, while the human retains 100% of the accountability for the final outcome. Why is this the ultimate verification step? Because AI, fundamentally, lacks contextual understanding, ethical judgment, and emotional intelligence. A human must bridge that cognitive gap. How do we enforce this? By intentionally designing our business workflows so that the AI cannot execute high-stakes actions autonomously. It can draft the contract, but it cannot send it. Diving deeper, HTL is the ultimate failsafe against insidious threats like data poisoning or algorithmic bias. When the automated systems fail to catch a nuanced error, the human expert serves as the final, impenetrable firewall. Observe the human-in-the-loop workflow on your screen. It starts on the left when the AI generates a draft. This draft passes through automated safety filters, our first line of defense. But the flow does not go to execution. It stops at the critical checkpoint, human SME review. The subject matter expert acts as the gatekeeper. If the SME identifies a flaw, the workflow loops backward, forcing a revision of the prompt or the data. If, however, the SME applies their expertise and validates the output, only then does the flow proceed to final execution or decision. This diagram proves that automation serves the human, not the other way around. We can preach about verification all day, but if we don't make it easy, people won't do it. We must design workflows that actively facilitate verification. What does this mean? It means structuring our user interfaces and business processes to actively encourage users to check the AI's work. The basics involve decreasing the cognitive load using clear UI cues and intentional friction points, so validating facts feels natural, not exhausting. Why is this critical? Because human nature dictates that if verification is tedious or hidden behind menus, users will skip it, dropping them right back into the danger zone of over-reliance. How do we build this? We use cognitive forcing functions. These are design choices like mandatory confirmation dialogues before saving AI data or highly visible, clickable source links. A deep dive into user research reveals a fascinating risk. Sometimes, just seeing a citation link makes a user trust the AI completely, even if they never click the link. Therefore, our workflow design must force engagement with the sources, not just display them. Take a look at this UX design concept map. At the top, the core objective is UI facilitates verification. This branches into 3 actionable design strategies: clear citation links, highlighting AI uncertainty visually in the text, and implementing cognitive forcing functions like confirmation screens. Notice how all 3 of these design choices funnel down into one critical outcome: reduced cognitive load. By making it mentally easier for the user to check the AI's work, we effortlessly arrive at the final, desired state at the bottom: a higher rate of human verification. Good design drives responsible behavior. Let's lock in these concepts with a real-time, highly impactful business use case, the executive strategy report. Imagine a financial analyst rushing to prepare a high-stakes summary for tomorrow's board meeting. In step 1, AI generation, the analyst prompts Copilot to synthesize both internal financial spreadsheets and external market news. The AI produces a beautiful, confident draft in seconds. But the analyst knows this is a high-risk task. So, in step 2, they perform citation checking. They systematically click the footnotes, verifying that the AI's external claims perfectly match the linked market reports. Next, in step 3, they apply human-in-the-loop review. Applying their deep domain expertise, the analyst spots a subtle but dangerous error. The AI made an ungrounded inference, misunderstanding an internal pricing policy. The result: the analyst manually corrects the flawed paragraph before saving the document. By selecting the appropriate verification steps, citation checks, and expert human review, the analyst prevented the board of directors from acting on hallucinated financial guidance. That is responsible AI in action. Our final flowchart maps the journey of the financial analyst. It begins at the top when the analyst prompts Copilot, leading to the AI generates board report. But the process doesn't end there. It hits our first verification gate, the citation check. The analyst clicks external links and successfully validates market data. The flow then moves to the ultimate gate, human-in-the-loop review. Here, the SME applies their brainpower and spots an internal error. This drives the flow to analyst corrects policy flaw. Finally, because the user actively verified the data, we arrive at the optimal outcome, a verified and safe board presentation. Technology drafted it, but human verification secured it.